Today, we're going to learn how to iterate through a map. Hello, I'm James Helfrich. A map stores a collection of elements by the key-value pair. And these are stored in the most convenient order for the map, which is sorted order for the key. But how do you iterate through them all? And what are you going to get when you dereference the iterator? This video will demonstrate both those things. To see how the map iterator works, let's take a look at the UML class diagram. So the map iterator simply has one instance of a BST iterator. Notice how the map iterator only has one member variable, it, and it's a BST iterator. And all the methods for the map iterator are a very thin wrapper for the underlying BST iterator. For an example, the maps dereference operator, presented in C++ below, simply dereferences the underlying BST's iterator. To see how this works, I'll have a map of float string, where float is the key and string is the value. What I'm going to do is I'm going to insert a bunch of GPAs, which are the floats, and the letter grades, which are the strings. Now I can use the m.insert, or I can use the array index operator. Either one will insert them the same. Now I've inserted these in a very specific order, so I get a balanced binary search tree. Observe how every node in the binary search tree has two values, the key on top, which is a float, and the value, which is a string below. We're going to sort the binary search tree based on the key. We're not going to sort it at all based on the value. Now, what I'm going to do is iterate through these backwards. I'm going to use the reverse iterator, which means I'm going to start on the far right, and I'm going to work to the left, and plus plus will take me to the left. If it was a forward iterator, plus plus will take me from left to right. Now, if it's going to begin by saying map.r_begin, which is going to be on the far right. The way this works is I'm going to start at the root. I'm going to keep going right as long as I can keep going right, and that takes me to the rightmost node, which in this case is the key 4.0. Now this iterator is going to have two values, the first and the second. The first will be the key, and the second is the value. So when I see out it arrow first, I'm going to get 4.0, and it arrow second will give me A. Now when I say plus plus, since I have no left node, I'm going to go up to my parent, and that's going to give me 3.67 and A minus. Once again, since I have no left node, I will go up, and that gives me to my parent, which would be 3.3, and that's a plus. Now I do have a left node, so I go left and as far right as possible, and this takes me to 3.0, which is B. Now, since I have no left node to go to my parent, which would be 2.67, now I have no left node, so I go up to my parent and as far left as I can, which takes me to the root. And this would be 2.3, which is C+. Now, I do have a left node, so I go left and then as far right as possible, which is 2.0, and it's a C. Since I have no left node to go to my parent, since I have no left node to go to my parent, now I do have a left node, so I go left and as far right as possible. Now, since I have no left node to go to my parent, and I do have a left node, I go to my parent. From this point, I have no left node or right node, so I go all the way back up to the root, and then the root's parent, which is the null pointer, which is the end, and I'm finished. Now, of course, the BST iterator is doing most of the work. You have to look at the BST chapter, the C++ data structures textbook, to understand how that is implemented. Let's take the same code and break into the debugger. Now I have the breakpoint set at the for loop. So I'm going to first stop before I execute the iterator, and I want to take a look at what the map looks like. Now when I expand the map, we're going to see all my different elements sorted in key order. In other words, the key starts at 0.33, then 0.66, and so on. And then when I expand it, we're going to see that these are a tree. The underlying data structure of a map is a binary tree. Now I'm going to take a look at the iterator. And the iterator also is going to have my key value pair, but when I start really diving into the implementation details, we're going to see that that the iterator points to a single node, and a node has a pointer to the parent, the left child, the right child, as well as has a color. And that color is going to refer to its red-black color because the binary search tree keeps this in a red-black sorted order. Okay, now right now by default you can see that we're using the less than operator to support our tree. But what if I use the greater than operator? Now when I break into the debugger, we'll see that we're also sorted by key, but not from smallest to greatest, but now from greatest to smallest. And so specifying the sort order through that third parameter allows us to order our map differently. This is example 16.1 in the C++ data structures textbook.